Hi everyone, welcome to another edition of ExpoLab Blockchain Speaker Series. And today is my great pleasure to introduce Aaron Soskin. He is the founder and Govrn, and his sort of inspiration has been, I'm kind of going to quote Aaron himself, giving people a voice and power in politics and democracy. And I think that's sort of the foundation of blockchain and sort of kind of using this decentralization and democratization technology to reach that ideal. And some of his, I guess, hobbies kind of resonate with me as well, especially reading those Federalist papers. Those are really interesting pieces of literature. And of course, Tahoe and the hiking in the Tahoe, I think that's a that's an amazing endeavor as well too. So without further ado, please take it away.
Yeah, thank you, Mo. Thanks for having me. I really appreciate it. I'm excited to be here. And as long as we're going through, I know, Alex, we're going to get to you at the end. So let me know as we start to approach that time. So let me go ahead and share my screen. Cool. Once you guys can see it. Yep. Awesome. It's in presentation mode. Perfect. Cool. So yeah, like Mo said, my name is Aaron Soskin. I'm the founder of a company called Govrn, where we aim to give people the power back in politics. And I'm going to talk a little bit more about that later. But really what I'm focusing today's conversation on is game theory and mechanism design, which I actually think is one of the, is a part of blockchain that is the least spoken about item. So I'm really excited to speak to you guys all today. So real fast, who is Aaron? Like Mo said, I was born in the Bay Area, but I grew up not that far from Davis in Sacramento. I wanted to be an astronaut when I was a kid. Previous jobs, I was a management consultant, a dairy farmer, and a production assistant. Loved skiing, concerts, the Giants. I got into blockchain about 3.5 years ago. And my hot take is that ranch dressing is the best food pairing condiment there is. There is nothing I wouldn't put ranch dressing on. It's incredible. There's two things I believe in: ranch dressing and blockchain. So what are we going to be talking about today? We're going to be talking a little bit about what game theory is. I'm going to give you a teaser, a little bit of icebreaker, talk about the prisoner's dilemma, and then we're going to talk about mechanism design. And specifically, we're going to talk a bit between those two different ideas: what game theory is and versus what mechanism design is. And as engineers and as developers, how you can apply that to make better applications. Cool. So a model about thinking of Web3 or blockchain, right? I love memes. There's going to be a lot of memes in this presentation. I hope you're okay with that. But a lot of people, when we talk about blockchain, really only talk about Web 3.0. And what do I mean when I say that? They're talking about the mutability of it. They're talking about how to distribute a ledger, but they forget about what the core key idea of why Bitcoin and Ethereum was so revolutionary, right? If you think about it, distributed ledgers had been around long before blockchain existed. Distributed computing, cryptographic hashes, all of these ideas have been around for a very long time. What makes blockchain, what makes Bitcoin so revolutionary is it combined this idea of execution environments, distributed databases with game theory components. And it invented this thing called proof of work as an economic model to ensure everyone coordinated correctly, right? And that's what I call it the Web 3.0 plus. And that's what I want to get you guys to start thinking about today as you start to learn more about blockchain. So first off, I want to give some acknowledgements. A lot of this material was taught to me by 3 professors that I'm very appreciative of: Joshua Gans, Steve Tadelis, and Kevin Bryan. So acknowledgements to them for helping me out. So the first thing is I have a quick teaser. I want us to all to kind of learn what game theory is. So I have a game. It's called the P Beauty Contest. Okay, and so everyone needs to pick an integer whole number between 0 and 20. And I have a prize for the winner, but the goal is everyone's going to submit a number between 0 and 20. We're going to take everyone's number and compute the average. And the person that guesses the number that is closest to 75% of the average is going to win a prize. Okay? So again, everyone is going to submit a number, and you want to submit a number that you think is going to be 75% of the average of the class. So to do that, click on this link here, or if you scan this QR code, you can also, you'll be able to go to the thing, to the Google Forms to submit it. I'm actually going to put this in the chat window or in the chat for you guys all to go to it. I'm going to give everyone a couple minutes. So there's the link. So you all have 2 minutes to submit a number between the 0 and 20. And again, you want to submit the number you think will be closest to 75% of the average. Okay, so everyone's got 2 minutes, minute to do that now. Perfect. Okay, cool. We're gonna close it now, and I'm gonna show you. Sorry, is my screen still presenting? Cool, yeah. Perfect. So this is what we have right now. Does anyone want to take a guess on what they think the answer is? Like what they think it is?
12.
12? You are right on, my friend. So the answer is 75%. The average ended up being 18, and 75% of the average ended up being 13.5. So the person that's closest, I'm going to say, is, we'll go with the 12 people that guess 12, they were the closest. So that is Alicia, Yuhu-san. Sorry.
Wait, isn't 14 closer though?
Oh, you are right. My bad. My mistake. Thank you. I didn't see the 14. So 14 is actually the winner.
But wait, some people guess like 50 and 99, so those should be discounted because they're not from 0 to 20.
You'd think, true. But hey, man, that's not the rules. They messed up.
That'll bring the number down.
Cool. So 75%. You guys said 13.5. Mo said you get an automatic A in this class. So Cameron, you got an automatic A in this class now. So that's the way it works. So let's walk through this, right? What is this? What were we really testing here? Okay. The way that this works, right? If you think about it, when you're trying to guess 75% of the average, you're guessing your guess is based off what you think other people are going to do. And that's game theory. Game theory is all about making decisions based off what you think other people are going to do. So let's walk through this. Things to consider. What's the max number the average could be? 15, right? Because if everyone guessed 20, 75% of 20 is 15. So 15 would be the highest number that anyone should ever guess. And if I think someone's going to guess 15, then I'm going to guess 75% of 15. And then someone else is going to guess 75% of that. And if that means if everyone is a rational player, we're all going to be guessing 75% of what we think the other person are going to guess. So if everyone was being rational, what does that mean we should guess? It means if everyone was rational, we should all guess 0 or 1. Because that's 75% of 75% of 75%, and it goes on and on and on. And that's how game theory works. But the thing you have to remember when you're designing games is just because 0 or 1 might be the smart answer, it was not the right answer, right? And what does that mean? Not everyone thinks rationally all the time, but a lot of people do most of the time. So what we have to do as we design applications is understand what is the right balance between the smart answer and the right answer. And that gets us to the idea of game theory and mechanism design, okay? And so game theory is the tool to understand people's incentives and how they react to one another. And mechanism design is the tool on how to design an optimal algorithm for a given game theory. So based off of what we think the incentives are for a game, mechanism design is designing game or a mechanism to optimize the game for the desired outcome that you want to reach. Okay, and what I like to say is here, game theory is the idea that like if someone pushes you, you're gonna fall down. Mechanism design is telling someone, if you push me, I'm going to hit you, right? I've designed a mechanism to stop you from executing your incentive, right? And like I said, this is the memified version of game theory and mechanism design to me, okay? And nothing really better explains this than the prisoner's dilemma. Have you guys all heard of the prisoner's dilemma before? It's this pretty famous example, right? And essentially, this prosecutor takes these cops take 2 prisoners, and they put one prisoner in one room and one prisoner in the other. And the cops want the prisoners to snitch on each other. And the game theory is that they know each prisoner is going to operate in whichever way gets them the least amount of time in jail. That's their goal, okay? So and the prisoner, each prisoner knows that the other person is always going to act in their own self-interest. Okay? So what we have here is if both prisoner B and prisoner A stay silent, they cooperate to each other. They each serve 1 year. Okay? If one prisoner stays silent and the other prisoner betrays them, the prisoner that betrays goes free, and the prisoner that stays silent gets 3 years in prison. And the same deal, the cops offer that same deal to prisoner A. And so the cops have told both prisoners that the other one, if whoever snitches first, goes 3 and the other one goes to jail. So what ends up happening most of the time? Both of them ended up betraying the other one, and they each serve 2 years, right? So the game theory in this is that each prisoner wants to reduce the amount of time they are going to spend in jail. And so the cops have designed a mechanism so that they optimally have created a mechanism where both prisoners are going to end up betraying each other and end up serving 2 years. Okay? And so now the mafia, or like the game, like the other side of that, designed their own mechanism, and they changed the game, right? Again, we're all basing off of other one's ideas. And how did they change the game? The first thing they did is they changed the probability for each item, right? The mafia would say, if you snitch on each other, we will with 100% certainty. Then they change the payoffs, kidnap your family and break your knees, right? Like if you snitch on each other, we're going with 100% certainty, kidnap your family and break your knees, right? And they also change the number of times the game is played. And the mafia is for life. You can never leave the mafia. You're going to continue to play this game over and over again. So essentially what the mafia did is they changed the mechanism so that the best probability and payoff ratio is not in defecting, but it's actually in just staying silent, and they each serve 1 year. Okay. And this, and just to hyper rotate on this, the question you have to ask yourself is, are you playing a single game, or are you playing an iterative prisoner's dilemma? And so if you mathematically like forecast out playing the prisoner's dilemma, multiplying the probability versus the payoff for each one of these, if you only play a game once, it naturally occurs where everyone should defect. But if you're playing the game multiple times, people naturally end up cooperating, right? And the simple explanation is this: fool me once, shame on you. Fool me twice, shame on me, right? Basically, like, if you fool me once, I'm never going to cooperate with you again, right? The technical explanation is the current net present value of cheating doesn't outweigh all future net present values of cooperating, right? Maybe if I cheat right now, we both get a unit value of $1, but if we cooperate for 100 years down the line, and every year we cooperate, we get $1, then I will end up getting 99 more dollars from cooperating today versus the $1 extra I would have gotten from cheating with you tomorrow, right? So the goal that we should talk about is, how do we change games from a single prisoner's dilemma to an iterative prisoner's dilemma, right? Again, prisoner, broken kneecaps, keeping mouth shut, right? So now I want to move into well, first off, let me stop. Are there any questions on what I've talked about so far? Cool. So let me kind of keep on going. So the next piece is next mechanism. The next part of this presentation is all going to be about different mechanism designs that you can build in a blockchain world. Okay. And my goal is just to start getting the wheels turning on new ways you can design your applications. So the first one that I find is not really talked a lot about is the idea of called sub-game perfect equilibrium. Okay. And I'm going to give you an example, and I'm going to show you how it applies. I love buying tickets to concerts, or at least when we weren't in a COVID time, we could go to concerts. I love buying tickets to go to concerts. And the problem of buying tickets online is that you never know if you should send the money first without getting the tickets and that they'll be faked, or you're trying to convince someone else to send you the tickets before you send the money, right? And people don't really trust each other, and so you got to find a way to make them trust. So buyers are worried that they're going to send money without getting tickets, or that they'll get fake tickets, and sellers are worried that they'll send tickets and never get a payment. So what are the incentives behind this game? What would rational players do versus nice players versus normal players? And so how can we apply something called sub-game perfect equilibrium to fix this? The first thing you do, and I'm going to give you a narrative example, and then I'm going to show you the probabilities behind it all. So the way that I would create a mechanism to fix this problem is the following. The seller submits a ticket to a smart contract, and a buyer submits a payment to the smart contract. Once both are submitted, the ticket goes to the buyer who has a choice. The buyer can either challenge that the ticket is fake or accept the ticket. If the buyer accepts the ticket, the payment goes through and the seller receives the payment. The transaction has ended. But if the buyer challenges the ticket, they have to pay 50% additional of the ticket price. The game then can go back to the seller, right? The seller then can accept or challenge the buyer's challenge. And I notice a lot of challenging and accepting. So I'm going to go to the next slide because it's going to make it a lot easier. This is the seller and this is the buyer. So the seller sells a real ticket. Let's go the fake ticket route first. Let's say the seller sells a fake ticket. The buyer can accept the fake ticket. This is unlikely, right? They would never do this. So the buyer would challenge the ticket's legitimacy, and the seller at that point can either accept the challenge, right? Which means that they accept the fact that it was fake, or they challenge the challenge, challenging it that it wasn't fake, and it goes to an arbiter. And the arbiter looks at the ticket and says, yep, this is a fake ticket. In that case, the seller has lost money, right? So there's no incentive for the seller to end up trying to sell the ticket. Let's say the seller sells a real ticket, and now the buyer claims it to be a fake ticket. To challenge the ticket, they have to spend an extra 50% of the ticket price, right? And if the seller then accepts the challenge, then the person that claimed it to be a fake ticket when it was a real ticket ended up not having a ticket and losing money, right? If the seller sold a fake ticket and accepted the challenge, they also lost money because they sold a not real ticket. So again, what we have done here is we've designed a mechanism where the only solution where people are happy in the end is if they sell a real ticket and the buyer accepts it. Okay. I'm not sure if you guys have seen probabilities like this, but these are a way to represent the payoffs based off probability and benefit of a person. Okay. So again, we have now designed a mechanism that says rational players will only ever sell real tickets and will only ever pay for real tickets, because it doesn't make sense to do anything else, right? So why would anyone use this platform? People that really only want to buy real tickets or sell real tickets would use this platform, right? That's the goal of what we're trying to do here. So another example of what this is, right, is in auctions. A lot of people think that there's only one type of auction, American auction or English auction. That's like the most common type of price, right? What's the game theory behind an auction? The game theory behind an auction, it's all about trying to get the best price for outbid everyone to get something you want for a price that you are comfortable paying. Okay, and so again, there are different types of auctions, which are mechanisms designed to encourage different types of behaviors or different types of games. Okay, so the one that we are most familiar with is an English auction, for example. This means it's ascending open bids until no one outbids the current bid, right? So the winner pays the last bid. So I bid $10, Alex bids $11, I bid $12 again, Mo bids $15, and then no one else bids, so Mo pays $15. That's an English auction, right? A Dutch auction, which is similar, it's descending open prices until a bidder takes the price, right? So again, the winner takes the bid price. So a Dutch auction is a reverse way where people are descending until the seller decides they want to sell at that point, right? One that I find super interesting that I'm surprised I didn't use more often is actually sealed second price. So in this model, let's say we're all bidding on a certain item. In this model, everyone submits their bid for the item at the same time, and it's all a secret. So let's say me, Alex, and Mo all wanted the same item. I bid $10, Alex bid 11, and Mo bid 15. Mo is the winner because he's bid the most, but he actually only pays the second price. So Mo, even though he bid 15, only pays $11, right? And basically we're creating a mechanism that gets us the true price discovery, because now we know what the price people should pay is, $11. Mo was willing to pay 15, but because the second place was 11, he only pays 11. So again, I'm going to show you the next advanced level of that, which is another type of auction called Vickrey-Clarkman Grove, okay? Which maximizes social utility by maximizing the highest combination of what bidders are willing to pay, all right? And what's happening here is the winner pays the marginal price harm to other participants. So I'm going to explain a VCG auction because I actually think it's super interesting. It's a little complicated, so let me know if there's any questions as I talk through it.
So this is pretty fascinating. Those, especially the third one, are they kind of studies? Which one would be more beneficial to the seller? Which one would be beneficial to the buyer? Because this sealed one seems very interesting in particular, especially if you get into the emotion of the buyers, then there's almost no bound. I mean, you really don't have any. Yeah, it could go anywhere.
Exactly, and that's the idea, right? It's like we like to sometimes in this world we like to believe in absolutisms, right? That there's only one right mechanism, or there's the best idea that we need to do, and that's not the case. Every scenario, every application, every market you build for has different game theory incentives built into it. Our goal as application builders is to understand the incentives that exist today and then build mechanisms that play off those incentives to get us to the optimal world we want to live in, right? Like our desire as application builders is to take the current state, create some kind of application that gets us to a better future state. The way we get to a better future state is a combination of understanding incentives and behaviors and building a mechanism that plays off of existing incentives to get them to act a certain way that gets us to a better future behavior, right? And so exactly like what you're saying, Mo, my goal of telling about these different types of auctions is to start to challenge our thinking. What is the right game? Like, not every situation is the same. One, who is the stakeholder you are building for? Two, what are their incentives? Three, will they act rationally? Based off those three questions, let's design a mechanism that makes the most sense, right?
I'm going to say one more thing. I think it's fascinating, and this is first time I'm kind of sort of brainstorming on the topic, especially the way you explaining it. It's fascinating to design those gaming strategy to get into that ideal place in society, but to speak a little bit more controversial and considering that we really talk about building this perhaps ideal democratic society, instead of gaming, maybe educating might be a better route.
So,
because you talk about gaming it to get there, and in gaming, by definition, there is exploitation involved. By gaming, I mean just the word gaming itself. You know what I mean? Yeah. There's a connotation in the word gaming itself, which is just sounds. I mean, it's very interesting.
Yes. So it's interesting. I actually disagree. Let me push back and disagree a bit. I'm going to go back to the prisoner's dilemma, right? Because in blockchain, we love to talk about prisoner's dilemma. We believe in a world where we want to make sure everyone cooperates. Like that is the future scenario. How do we get different people that don't trust each other to cooperate together, right? We create games not to exploit people, but we create games so we create the right incentives so that makes more sense for people to cooperate rather than them defect, okay? And what I'll actually do is I'm going to skip the VCG auction. I'm going to talk a little bit about Govrn because I think it might make a little bit more sense then.
No, it makes perfect sense. I mean, I totally understand that you are gaming and you're trying to adjust the behavior in order to get to that ideal scenario, and you're constructing a sophisticated and a very thoughtful games. But I'm just saying, there's also a completely different way of doing it. Is also educating.
Totally.
It's to educate, to cooperate in order to get in a more ideal place. Again, it's not a replacement, but I'm just talking about a more perhaps a philosophical aspect of this. You can game it, but you can also educate it.
Yes. That is true. So like, there's two ways, right? We can do it, right? Like you said, if you can educate everyone to be like, and show mathematically why it's actually in everyone's best interest to cooperate, right? That's like the ideal. And if we can, like, we should definitely be doing that because that's the only way that we can get to that future state.
And I'm just going to say one more thing. I mean, if you actually, since you like, I mean, since you mentioned the Federalist and kind of, I guess, go on the philosophy aspect, is that, I mean, Plato and Aristotle, they do talk about, can you build a just society by only making people to blindly follow? And creating a just society by blindly making people follow, it does resemble, in a sense, gaming it. So as a result of the game, they get into that ideal state, versus creating a just society by educating the people. So people knowingly taking those steps in order to get to that just society. But again, this is nothing to do. This is kind of slightly bigger scope. But since we're talking about governance, I think that's also governance on education, governance gaming, and I think that's an interesting.
I definitely agree. And invite me back, and we'll dive specifically into governance a lot more. I'd love to do that. But I think it's a great example what you just brought up. Let's talk about the Federalist Papers, and let's talk about how it all came about. So for people that aren't familiar, the United States had fought the American Revolution, and they broke independence from England. And the first thing that we did when we broke independence is we actually created something called the Articles of Confederation. Which was a confederated agreement of 13 colonies in America. And we did that, and that was actually the first 4 or 5 years of America's existence, these Articles of Confederation. And it didn't work, right? Basically, we created this idea where we didn't build that many mechanisms in. It was a kind of a free market of governance, and there was a bunch of revolutions, or there was a bunch of like civil unrest. A lot of states started fighting. There was infighting within the states, and America was like almost going to recollapse. So 4 or 5 years after, the constitutional conventions happened, where there's two schools of thought. The Federalists, who were in support of a strong federal government, who wrote the Federalist Papers, and the Anti-Federalists, who thought that the Constitution was overreaching. But if you think about it, all the Constitution was a mechanism. It was mechanism design at its finest, right? It said, hey, we spent 5 years understanding the incentives of Americans. Americans are going to do X, they're going to behave like Y, and they're going to behave like Z. That's what's going to happen. What we're doing right now isn't working. So let's design a mechanism called a federal government that's actually going to force players to cooperate, either by laws or by rewards. And that's what the Constitution was. The Constitution was a mechanism design document for the incentives that came out of the American Revolution. So I think it's fascinating to look at how it's kind of advanced. And so specifically on governance, so we could definitely dive into that at a time too. If I had more time, I'd love to, but I want to make sure we can talk about Alex's stuff too. So governance, politics, and voting. And so I'm going to talk about two examples here. One is a new kind of voting mechanism, which is really exciting, called quadratic voting. And the other one is what we use at Govrn. So quadratic voting is this new idea that's getting really popularized right now. And it takes the idea of collective decision-making procedure where it allows individuals to allocate votes to express the degree of preference rather than just the direction of preference. For example, think about it right now. When you go vote for a candidate, you vote yes on one and no on the other. That doesn't really show you how much you agree with one person or disagree. You could actually not really have any preference, where other people could have a huge preference difference. So the way it tries to account for that is by something called quadratic voting. And it allows you to vote multiple times. But the way it makes sure that it's not ruled by individuals that have big money is it costs quadratically more to buy each incremental vote. So if you cast one vote, you only have to pay $1. So for example, if you want to cast 2 votes, you have to pay 4. If you cast 3, 9, 4, 16, 5, 25. And so what it allows for is it still allows for people to represent their preference for a specific option, but it doesn't allow for people with the biggest amount of money, the most money, to be able to dominate the majority or to dominate all of the voting, right? Because if you do have such a strong preference, for each marginal vote you take, it's going to cost you exponentially more. And so what we're trying to do is by using this game, designing a mechanism, it flattens the difference between the lowest, the least wealthy person, the most wealthy person. It flattens the difference while still allowing for preference to be considered when you vote. Quadratic voting doesn't work in every single situation, but it starts to be a voting mechanism that is designed for a specific type of scenario that we need to account for. I highly, highly, highly recommend checking this link out by this post by Vitalik, who invented Ethereum here, where he really dives into quadratic voting. I'm not nearly good at explaining it. And so finally, I'm going to talk a little bit about Govrn, okay? And the mechanism we have designed for game theory. So the game theory that we believe in Govrn is that for better or for worse, money is going to be in politics. We want it out of politics really badly, but it's really hard to get out of politics for a lot of different reasons. And the truth is, both politicians hate money in politics and constituents hate money in politics, but they both do it because no one is willing to take the first step, right? So you're kind of stuck in this prisoner's dilemma, right? Constituents want to give money to politicians that are fixing issues, and politicians want to spend all of their time fixing issues. The problem is, if politicians spend all their time fixing issues and no one gives them any money, then they don't have any money to run for re-election, right? And constituents don't want to give money to politicians that end up not fixing their issues. So what ends up happening the most of the time is we don't give money to politicians, and politicians spend all of their time raising money instead of fixing issues, right? Again, if someone gives money and the politician doesn't fix the issue, the constituent feels like they were left holding the bag. If the constituent doesn't give money and the politician spends all their time fixing issues, it ends up being where they lose re-election, and it's not a desirable outcome. So at Govrn, how do we use those incentives to get everyone to cooperate together, okay? And so we designed a mechanism called outcome-based donations. And outcome-based donations are donations that are held in tech-enabled escrow contracts until predefined community metrics are reached. For example, once a politician reaches a metric, they receive a donation. For example, like I really care about homelessness. So I could donate $100 to the mayor of San Francisco only if homelessness is reduced by 2% in 4 years. And if that metric is achieved, then they get my donation to their next political campaign. So what have we done? We've changed 3 things and moved us to cooperate. We've changed the probability of each option by putting money in escrow and defining clear requirements of whether or not that money is unlocked. 2, we're changing the payoffs for each option. And 3, we've changed the number of times the game is played. And we're changing it from a single option of only asking for money once to an iterative option where people can fund multiple things that they want to get done, right? Again, we've now created a mechanism that incentivizes politicians to spend more time fixing issues than running for re-election, because they know when they fix the issue, they'll make the money they need to run for re-election. So again, it's all about understanding the incentives of how the game is played and building mechanisms to design it. And the final thing is, like, why does all this matter? Okay. And I really wanted to hit on this idea for specifically engineers, because I think it's passed over pretty frequently. It's because no one really gets excited about digital ledgers or mutability. Like, you can go say to, like, trusted execution environments, we can go start preaching these ideas and building applications where we only talk about blockchain. But if all you ever mention is blockchain, you're missing the point. Everyone gets excited to see the new world you're creating. Everyone gets excited when they know they can cooperate with one another. And that's a fascinating idea. And that's what we want to be building. We're not building blockchain applications. We're building the next version of the web, right? We're building these new applications that are going to take us to new levels of cooperations where we can trust one another without ever knowing each other. And that is a fundamental paradigm shift that gets glossed over way too often, right? And so again, developers sometimes are confused why no one's playing their game because they talk about blockchain a little too much, right? And the goal is not to just put something on a blockchain and call it a day. The goal is to look at the unique properties blockchain enables and build mechanisms that are going to take us to the future, a better future, right? And ultimately, when we can start combining our engineering ideas with mechanism designs, we can make some fire blockchain apps. So again, that's the presentation. That's it. I hope this was informative. I hope this gave you guys a different lens into the view and world of blockchain. I think sometimes too often we focus on the technical aspects and we forget the key innovation. And again, the key innovation is how to build mechanisms to actually shift paradigms to a world where we cooperate with each other instead of this extractive Web 2.0 environment that we live in today. With that, I did so much talking. I hope I'm around. Feel free to email me, reach out to me on Twitter if you guys have questions. I'm happy to talk about mechanism design. I'm happy to talk about politics, democracy, the Federalist Papers. If you're interested, right after this call, I'm leading a discussion on the anti-Federalist Papers. Come on and join on. It's going to be a fun time. And so thank you guys. I hope you appreciate it.
That was wonderful. Thank you so much. Very exciting, very engaging, and very different perspective from what we have been looking at. So I think it's really inspirational in terms of the topic. So any questions from the audience?
Well, I think, yeah, it was fascinating. And yeah, it's really interesting how, yeah, blockchain is literally the applications of game theory on the internet. It's like on the internet, there's many strangers, they don't cooperate with you. If there's no rules that define what is cheating. And so blockchain, proof of work, proof of stake, they define programmatically what is cheating. So that we defeat the prisoners dilemma together. We defeat free riders problem together. We defeat all of those game theoretical holes that would happen because as humans, we are not wired to know more than like 100 people face-to-face, right? We're not wired to trust billions of people. So we need internet to scale that trust to the masses. And yeah, a great talk, Aaron.
Yeah, thanks. I think you guys can do a really good pairing with the mechanism design followed by DAOs. I'm like heavily involved in the DAO space as well, which is like, in my opinion, one of the most elegant and simplest like mechanism designs to get people to cooperate. So Alex, I can't wait to hear what you're going to talk about with DAOs, but like, DAOs is like literally changing the game when it comes to how we cooperate with one another. So yeah.
Thank you. Yeah. My talk will be a bit, it will be short and like it will be less technical as well, but it's such a great setup because yeah, like DAOs is basically enabled by what Aaron just said. So yeah.
So any further reading do you recommend, Aaron? I think Cameron mentioned the book, which looked very interesting, The Radical Market. Any other follow-up for those who are interested to kind of dive into this topic?
Yeah, there's a couple books on game theory that I can send over to Cameron. I don't have I forget the names off the top of my head. Specifically, there's some good academic papers out there.
Sure.
About how to apply mechanisms.
Sure.
Specifically,
Maybe
if you want to learn about, go ahead.
Mail it to me later. I'll share it with everybody. Okay. I mean, I'm interested myself to kind of, because I think it seems very fascinating.
Definitely. Yeah, we'll send that over.
Thank you. All right. So on behalf of ExpoLab and UC Davis, so let me take this opportunity to thank Aaron for this very exciting talk. And we're kind of going to transition to Alex Masmej. He is the founder of Alex Crypto, and he is the first human IPO on Ethereum. I hope he's going to talk about that as well because it sounded pretty cool. And it's part of the MetaCartel of DAO, and so it seems very exciting. So please take it away.
Cool. Thank you so much for having me, Mohammed. Yeah, I can maybe share my screen. I have a slide, but it's not. I don't have tons of slides, but yeah.
Yeah.
Can everyone see the slide? Okay, cool. So yeah, so my name is Alex Masmej. I've done lots of applications on Ethereum, which is like the smart contract platform where you can do tons of things, and it's fascinating. And there's so many things that today we're just going to talk about a very narrow use case. Well, not that narrow, but we're going to try to think from first principles and see what is new primitive that could not be made without blockchain. can exist, and like why is it so interesting. So DAO, let's talk about DAOs. So DAOs is an acronym that means Decentralized Autonomous Organization. And it's fascinating because in the history of mankind, I don't think you reinvent the way organization operates very often. Originally, I think there were some boats where investors would pay upfront the search of gold and other materials a few centuries ago, and they would get some percentage back of whatever was collected by adventurers or people like this. And that was kind of like the start of equity, which we now know well. And it works well in startups where entrepreneurs give up equity to investors. And so the incentives are aligned. And so this model works really well. We're all in California, where Silicon Valley is like an amazing startup ecosystem. But this model really did not leave the startup founder, venture capitalist, investor era at all. And this is the first time where there is a new primitive that can go further than this. So DAO, so it's 3 letters, decentralized. It's a means to an end, right? We don't want decentralization for the sake of it. The sake of it is defeating all the game theoretical holes like cheating that Aaron explained earlier in his talk. And so a great term for it is what Vitalik Buterin, the founder of Ethereum, described as credibly neutral, which means like we all agree that Ethereum, which is the platform for most organization, the DAO, like what is the balance of like the money, the voting power, all of those rules, they won't change on you. That's the main thing. This is why we want decentralization, is because we want to be all sure that the data and the information, because the DAO is going to hold some sensitive issue, sensitive value, right? Because it's like a company online, it's an organization. So you need like equity, you need like to have like some voting power, voting shares. Like I'm going to talk about this later, but first of all, you need to make sure that the rules won't change on you and that everyone is on the same page. Like there is no cheaters, no cheating allowed. Then the second part is very exciting. It's autonomous. Because in the startup world, you might have 3 entrepreneurs going after a product that solves a problem in a market. So this is 3 people, maybe they invest from like 10 different people, and it's 13 people, right? And so it depends on them. But the fact that this is decentralized actually enables the autonomous part, meaning that we can let anyone online, if we define the rules of helping out an organization, we can let anyone chime in. And a great organization, a great example of a DAO today that doesn't work with blockchain is Wikipedia. Because Wikipedia today is strangers on the internet just gathering to produce this massive encyclopedia of information autonomously. You don't need to appoint anyone. The person that knows the best about X topic will just rise to describe that, and it will be approved by the community. And we want to reproduce Wikipedia for many, many more things. And the reason why blockchain is interesting is because in blockchain, you have things like cryptocurrency, which enable to monetize. Wikipedia is not a for-profit organization, but what if you could create like giant organizations like Wikipedia with financial incentives that could create giants to the size of like Google or Amazon that we haven't even seen before. And so, yeah, of course, organization, this is the goal. So DAO is this sort of like company that is not incorporated anywhere, but on the blockchain. So it's not an LLC. I mean, now there are some examples of DAOs in LLC I will talk about later, but it's this sort of organization that lives on the internet. And it's insane. Personally, like I never worked at a company, but I worked at some DAOs. Like my career, I have been employed by lines of code. Like it's very, very interesting. And this is my entry in the crypto space. And this has never happened before in the history. Like there's no company online, like we talk about fintech and Venmo and PayPal and all the non-blockchain financial applications, but there's a bank behind it, right? A DAO is fully on the blockchain, is fully on the internet. And that's what makes it fascinating. So moving on. So yeah, the mission of a DAO is to scale human collaboration. So right now, maybe Apple or Facebook have maybe 15,000 employees, 20,000 employees, but there are not as many employees as open source organizations like Amazon, like Wikipedia and others, where like 100,000 people or even more, like what if 1,000,000 people were working towards the same thing online, because it was easy for everyone to chime in. And so this is what we want to incentivize. So this is the mission of a DAO. If like, just to remember, simply it's like scaling human collaboration. And instead of having equity and like something that's very strict with like founders and on the other end, like users of a product, what if everyone was incentivized to do something because they share the same incentive? And this is why in crypto, we really like tokens and cryptocurrency, because it's one easy vehicle to transmit equity to everyone. So in 2019, I mean, blockchain industry is so young, so like this is already old in blockchain terms. But last year, there's this DAO which rises, which is called Moloch, and basically it's an organization that lives online, and the mission is to fund Ethereum development. So it's kind of like dog fooding, right? It's like the mission of that company is to improve blockchain technology itself. Because it makes the most sense, and because like it's so complex to use, because blockchain is very early, that you would want to have like a use case that is literally the same industry. And so again, as Aaron said, this solved some game theoretical holes, because Ethereum is an amazing technology, but it's a public good, right? Anyone can use Ethereum, but everyone would benefit a ton if Ethereum 2 was being developed faster and developed quicker. Everyone would benefit, all the entrepreneurs, all the investors. The problem is, since Ethereum is a blockchain that belongs to everyone because it's decentralized, no one is really incentivized. And you have the free rider problem. That's a game theoretical problem, which is, well, no one will act. People will just sit and like wait for someone to actually improve Ethereum, since there is no incentive. And so what Moloch did is like, they said, well, let's create this organization online where instead of like, you know, Ethereum Foundation or like one organization saying, okay, we are going to fund a team of 20 people and take all the losses, they all coordinated to raise money together and vote on what project should be built with that collective amount of money. So this is, if you think about it, the first principle of any organization, whether it's a nonprofit or a startup or an enterprise. It's you have some funds that you vote and you decide on how to do. So for an enterprise, it's like you fund your employees and they build a product. For a startup, it's you raise a lot of money up front, and then you build a product and you test and you rapid prototype and you build an MVP, etc. And so since blockchain is so early and we have no clue really how this whole thing works and how to build those companies of the future, the Moloch DAO system was very easy, and it's just sticks to let's raise money together so that now we have way more funding collectively and we use our resources much more efficiently. We collectively vote and we coordinate funding. Wouldn't that be great? And again, as Aaron said, there are tons of game theoretical holes in this, because you could just vote on something that is selfish to you and basically escape that whole premise. And so what did Moloch do that was genius and enabled people to still be aligned on what to fund? They introduced a feature called Rage Quit, which is every time a decision is being made with everyone's money in that internet like startup, people have a like window of a week or like whatever length you want, where they can get their funds back if they disagree with the decision. So that means that you cannot make any selfish decision with the collective funding, because if people disagree, they would leave that organization straight away without their fund being spent. And so this created this amazing collaboration on the prisoner's dilemma, where everyone is forced to cooperate. So this is one application that Aaron described. Like, this is solving the prisoner's dilemma, where now in Moloch, everyone is cooperating, because there's no way you're going to cheat. There is no way you're going to spend your money selfishly on your project. Everyone will collaborate and better use the collective funding that's there. And so what happened? Well, the founder of Ethereum themselves were very excited about Moloch DAO and gave 4,000 Ether to fund the development of Ethereum 2. And I'm actually extremely excited because for those who know, Ethereum 2 is launching today after 5 years. This is such an amazing milestone in the industry. And so from that success of Moloch DAO succeeding, at advancing Ethereum to development, MetaCartel, which is another DAO, and Aaron is also part of MetaCartel, decided to say, let's create the same concept, but instead, let's fund Ethereum startups. Let's fund Ethereum applications. Let's fund Ethereum hackathon projects, because we would all benefit as, I don't know, infrastructure or like enterprises that like, service those companies. Let's do something to fund them and help them, get started and like innovate more on the Ethereum application ecosystem. And so, yeah, like since it's open source, it's an organization that anyone can join. It kind of kept some internet culture elements like a meme. So like the logo is pretty informal. This DAO is extremely informal, and that's normal because it's the internet. Like anyone can, come to the Discord channels and Telegram channels and chime in, and anyone can help the DAO. And if they are helpful enough, they will get shares and equity in that software organization. So that's fascinating. And so, yeah, MetaCartel funded a lot of applications on Ethereum. I'm not sure if you dived deeper into what can be done in Ethereum, but they funded many smart contract applications like NFT, which are digital assets, or an applications for like events where you could get paid if you attend an event and you lose money if you don't attend. So it's like another blockchain incentive, funny game where people are like paid to go to events. Or DeFi, which is like the main use case of crypto today, which is financial products built on top of Ethereum. And so MetaCartel actually succeeded pretty well. And so there's some learnings that we can understand from those extremely novel way of coordinating, which is we should prioritize people over the technology. So it's not because we can vote on this blockchain ledger to decide on funding that we should do it. We should use technology like it should be used, which is as transparently as possible. People should not be aware it is the blockchain. People just want to get things funded in that like small use case, like of the DAO for funding. So basically, there is no quorum on the Moloch DAO ecosystem, meaning that only one person can say yes, zero can say no, even if there's thousands of people, and the proposal will pass. Just because we have that rage quit window where people can disagree and leave if they don't want to. And so the benefit of this is that basically just one person can vote. No one has to click on it. There's way less friction. And so if people agree and are aligned on that mission, they probably won't disagree. And that's like the magic of it. And we don't have to like go on a website and click and vote, because maybe this is like for people, like this is not as attractive. They just want to be part of a mission and not be like always hands-on and voting on things. So really make the tech as invisible and light as possible. And then, so how to scale the decentralized organization ecosystem to the masses? Well, there's many different ways of doing it, and I didn't update the slide, but there's this project called YFI, which is extremely fascinating, called Y on Finance, and it's a financial product that optimizes for the highest yield, so the highest return on investment for financial products on Ethereum. And it's a robo-advisor, so like it automatically goes to like the highest yielding product. And so what happened is that it's an open source DAO. Anyone can, chime in, do some work, update the smart contracts. And so what happened is that people could work for it and gain YFI tokens, which are very expensive today. So like you could get real money from this. And for the first time in history, people started to work full time for lines of code. Like this is not a company. This is not incorporated anywhere. There's one sole founder that's like kind of anonymous. Like we know who that person is, but they're not particularly like, entrepreneurial or anything. They just like started to write some smart contracts, and people started to leave their full-time job to work on this, where the protocol was at the center and the humans were on the edge just working for that protocol. And it's never happened before. Like if you know about startups and program and Y Combinator, they always say, you have to start, you have to be in person, you have to be 3 people and focus on one thing. And the DAO is the first time we are contradicting a lot of Silicon Valley's best practices. This is an insane new frontier. And so I said gamifying reputation layer because you want to scale people helping you out. And so if you can make it so that, I don't know, if you share a tweet, you get some tokens and like equity in that DAO. If you, help out by coding and doing some pull requests or whatever metric, you could get some tokens. Like if you can gamify people helping you and going through the ladder, like the corporate ladder, but of this online new organization type, that would be really cool. And that would, enable thousands of people and millions of people to work at online organization with no founders, which is insane. And so now it actually grew pretty well. So MetaCartel DAO is now a venture fund that has no partners, that has no investors head. It's a venture fund that is now a LLC in the United States that's incorporated with real law. And the legal documents literally say, please refer to the blockchain code as the assets. And it's mind-blowing because basically, like, this fund is investing in Ethereum startups, and it's serious, and it raised millions of dollars from public companies in the United States. And we can see that the DAO movement is gaining pace and like being more and more serious. And I can see in the future, a world where you are an entrepreneur, you want to raise some funding, and you would just click a button to incorporate, and click another button to immediately raise like $100,000 from that DAO that voted in like an hour to decide whether to fund you or not, because everyone's will do due diligence on you, and like the collective wisdom of anyone on the internet on your startup will be enough to decide very quickly whether you deserve funding or not, which will basically enable so much more innovation than it is today. So that's fascinating. So yeah, anyway, that's this quick talk. I can answer some questions, but long story short, DAO is a new way to create companies, startups, enterprises, nonprofits, anything online, where equity is now a token on Ethereum or other blockchain. And yeah, so that was like my talk. Hopefully it's not too long. Yeah.
Yeah, Alex, real quick, explain Alex token and what NFTs are.
Sure. So I am mostly known in crypto for creating my token called Alex, which is, I was a student last year, and I was basically not very wealthy, and COVID happened, and I didn't want to get a job. And so what I created, and it's kind of like a DAO to a small scale, I created this token called Alex. And the mission of that token was, I'm a founder, I want to move to San Francisco, I want to start a startup. And if you believe in me and you think I will do well later, I will like do anything to reward the people, because by buying the Alex token, by earning the Alex token, I can see on the public blockchain that you supported me, because the blockchain is transparent. So right now there's around 500 holders of the Alex tokens, and I can see those addresses, and I can maybe give them equity in my future protocol, in my future DAO. I can just give them some shares as a thank you. Or I also said I will give some income sharing agreement of the money that I'm making for the next 3 years. So I did this as well. And you can also use the Alex tokens for accessing my newsletter, for accessing my Telegram chat and chat with me. So there's a lot of things that I did around my token to basically better communicate with people who support me and make sure to reward people who support me early. And I think this is the future of young entrepreneurs like me. It's the future of politicians that can be grassroots led and raise funding that way. It can be the future of athletes who want sponsorship deals that are crowdsourced. It can be the future of artists, where if you are early in discovering an artist, instead of being Scooter Brown discovering Justin Bieber, it can be the crowdsourced people just thinking that an artist is going to do well. And so all types of creators and figureheads of any movements can create their tokens. And it's just me. But if I say now it's not me anymore, and it's like 20 young people that are looking to do startups, now it's a DAO. The Alex token is just a very simplified version of a DAO, where the mission is solely around me, but it can be around an organization. So yeah, the same. So yeah, the Alex token is pretty cool. It's a funny thing that I did. Anyway.
So thank you so much, Alex. It's very exciting. So kind of stepping back, what are the interesting, I think, new application do you think would be suitable for funding by DAO? So if you were to sort of in an ideal world, what are the top 3 things that hasn't been arrived, kind of out of the box, maybe far-fetched, but if you get those in those type of application, it would be a real game changer?
So I think DAOs would be amazing for public goods. So and this goes back to Aaron talking about quadratic funding and other new ways of using blockchain. Blockchain is a public good. Decentralizing something means that you make it public pretty much, and anyone can access it. And there are a lot of things in the world. Most public goods in the world are underfunded. So for instance, open source software is a lot of developers which are way less paid than their private counterparts. And we need open source software. It's present in all of our devices. And it would be great if a DAO of, I don't know, like all the most like wealthy companies just directing like 2% of their profits directly to public goods. And this is what has happened in the crypto space this year, which was fascinating. Like, if I don't know if you all know DeFi, but there are some financial applications that made like billions of volume this summer. And so what they did is, like, as a DAO, they collectively voted to give some funding to open source software collectively. And so, you know, public goods can go beyond open source and computer science stuff. It can also be like public health. We saw COVID, like public health is a public good, or the CO2 levels. The environment is also a public good. We all benefit if the environment goes better, but no one is directly incentivized to improve the environment. This is why there are lots of companies polluting in the world, because they don't really bear the entire cost. The entire cost is divided for every human being on the planet. So this, and then what else? I mean, of course, politics, governments, this is public goods by definition. And this is why it's so interesting. And so that's why I would push back on, you know, some people thinking that blockchain is for libertarians. I totally think that blockchain is a great collectivist like technology that can radically improve politics. And the fact that a DAO can decide much faster on decisions than normal governments is extremely exciting.
So political campaign, is that something that can be funded by DAO as well too?
I think so. We see like very interesting political candidates leverage the internet for their benefits. So of course, Donald Trump, which basically used Twitter as his platform, but also Andrew Yang, the past election, even though he didn't win, he was way higher in turnouts. I mean, in popularity than his background allowed them to, and like he used social media and things like this. And so with blockchain, you can incentivize people much more than traditional social media. You can say, well, you know what, like if I could give some donations of my campaign to you if you were my early backers via my token. Like there's tons of incentives that you can programmatically enforce that could incentivize more people to talk. Like, oh, if you call 10 people for like my candidacy for the United States presidential election, I will give you more tokens, or I will give you X. I think that would be extremely cool. And this is probably going to happen, but blockchain is a very early technology, and I don't see it happening like anytime soon. But I would say in the next few years, as pioneers like Aaron advance the space forward, hopefully we'll see some applications being built.
Sorry, Aaron, go ahead.
Yeah, I would just quickly second what Alex said. I think we're going to see this really soon. Especially the idea as political parties break down into more and more discrete units, we're going to see them run by DAOs more often. If you think about what a political party is, it's just a coordination machine for dollars to political candidates, right? And it's just the highest possible grouping. You have Democrats and you have Republicans, and we decided that we're going to trust these centralized groups called Democrats and Republicans to fund candidates that should align with our values. That model's breaking. Right. And as our ecosystem becomes more robust, we're going to be able to build DAOs to run political parties and have political parties get started out within like localities that never could have existed before. Right. DAOs coordinate people with an insane amount of precision and efficiency. So getting political parties to adopt that next is really exciting.
Yeah, if I could just add.
I agree.
I also think that the world of nonprofits can also benefit from this, and the amount of transparency and even automation on the bureaucracy. I think it's the closest entity that resembles a government that one can incorporate. And this is what we're doing at the Blockchain Acceleration Foundation. Mo is an advisor. The president of blockchain at UC Davis is a board member. And we're sort of taking this very compliant approach because we are a tax exempt entity. in slowly decentralizing the first tax-exempt nonprofit. So that is, it's still to be determined. It's a giant experiment right now, but how can we actually do this legally and compliantly? And what Alex said earlier with Moloch DAO actually being a legal institution and having like the law backing it is something that has not been explored very much. So if anyone wants to get involved, it's totally open to the public. We look for builders and people who are interested in pushing the space forward. And I'll tell you guys all more about this in another class, but nonprofits, that's my point.
That's really cool. Yeah, it's also one thing that we kind of, I didn't mention, when you decentralize something like a nonprofit, you enable composability, meaning that, you can program incentives to say, if you, I don't know, like share on Facebook that nonprofit and gain enough exposure, you can get X. But if it's on the blockchain and it's transparent and, you build platforms where anyone can leverage it, then maybe like a brand would just sponsor the nonprofits without even you deciding it. Like someone used Alex tokens to give out to people and this quick marketing stunts like 2 days ago without even telling me, because on the blockchain, everything is permissionless. You don't need permission to do anything. And so you enable the entire internet to help out your mission, even if you don't, even if you're not even aware. It's like APIs that people can call without any permission, without even talking to you. It's fascinating. So you can program incentives, but you can also let the public, the world, the internet, strangers create new things on top of you and add value to each party.
I'm kind of skeptical. Sorry, Mo.
Go on. No, go on.
Yeah, what's like, because I'm a little worried that, you might not want all the people in the world, leveraging the Alex brand. There are some bad actors out there. How do you prevent that?
Well, how do I prevent that? First of all, blockchain is a technology. People can dig in the smart contracts. And it is great to be censorship resistant and to let anyone, even the bad actors, but then because that's like we have to allow bad actors, that's literally the definition of Byzantine foster, like you need to have bad actors and the system should still continue to operate. But then there's a second layer, which is the UI. People will not dig the Ethereum blockchain and like the details. And so on your website, on your interface, on your platform, whatever, you can then, maybe like blacklist or do any kind of system that restricts people from seeing like the bad actors, collaboration, incentivization. Maybe you can have even like a seize function. So, USDC, which is a stable coin, always worth $1, operated by Coinbase, redeemable for $1 in Coinbase. They have an option in the smart contract to freeze funds. So if like there's some money laundering or illegal activities and you still want to get control of who's using that currency, Coinbase has the right to freeze the dollars and render them, valueless. So that's one thing that kind of breaches some decentralization desirable like elements. But if you want to, anything is encodable on the blockchain, including the right to censor.
Got it.
So any questions from the audience?
So I think to kind of like expand on what Aaron said, there's this amazing article which is called Meditations on Moloch, which talks about game theory. And this is basically like everyone who's in the blockchain industry that I know like read it, because it's so fascinating how basically almost everything in the world is a game theoretical problem that the blockchain could potentially solve. Like for instance, every country is spending millions of dollars, even billions of dollars on armies, right? Weapons and military. But no one is really, there's not as many wars as there is spendings in military. Everyone could decrease it and spend it in education or healthcare and areas that actually improve the world. But they don't, because if you defect, then you can be prey to attacks from foreign countries, right? And it's clashing incentives, and it happens everywhere. Like the media, which is sensationalism, clicks versus people actually wanting to read great news, but they're not willing to pay, and so it's again clashing incentives. And so if we could just align incentives, which is kind of like a meme in crypto because everyone says like align incentives all the time. Like if you could actually do one party, it just is great. And so yeah, Meditations on Moloch is great. It's a very long article. So if you don't want to spend too long reading this, there is also a podcast by Redemption Adams, which is very great. And it's shorter because it's like an hour. It's a podcast on like an hour long. So shorter time to read the whole thing. But it's fascinating because this is everywhere. And, you know, there's also the thing called Fermi paradox. Like I'm going a bit far here, but Fermi paradox says that, you know, civilization go extinct likely because we are alone in this universe so far. And why is that? And maybe one reason is that civilization auto-destruct themselves. And perhaps it's because of clashing incentives, because, you know, like there's arms race everywhere and we building more and more powerful weapons. And so maybe, and that's kind of crazy, but if we don't coordinate and blockchain is one solution, all civilization might go extinct long term. So like blockchain can literally save the world. Yeah. Anyway, yeah, I'm just so fascinated by crypto. And I hope like you stay engaged. Like feel free to add me on Twitter, Alex Masmej. My DMs are open if you want to chat or anything. Yeah.
Well, very fascinating. So as a blockchain, I guess, researcher and advocate, going to ask perhaps another controversial question. So these are all really great applications, but is it possible to realize them without a blockchain? Or is a blockchain is a necessity in order to, for example, micropayment or micro loans or GoFundMe? I mean, there's other potential alternatives, but why is it that the blockchain is going to really change the game plan here?
Well, if it's okay for like tiny applications to be centralized, and actually most blockchain applications start centralized, but if you want to build something extremely ambitious, and like that anyone on earth can like trustfully come and, you know, work on, I think it's necessary to be on a blockchain. And one example, for instance, is that if you're building a, you know, an application, there's going to be multiple languages, multiple cultures, multiple people. And if it's on the blockchain, anyone can build a front end on top of it. Everyone can build a website that uses the same smart contracts for a different language. And so if you have a centralized company, you will need to hire a ton of people. It's just not that efficient. Blockchain is actually more efficient if you want to build something and let just the internet leverage it by incentivizing those people. So, you know, you can always do, you know, you can go to a place with horses, right? But like blockchain is just a better way to coordinate at scale. We just cannot coordinate at scale very well without it.
Yeah, and just to expand on what Alex said here, like I think we sometimes just inherently have connotations of like centralization bad, decentralization good. And it's not that simple, right? Some use cases it's totally like blockchain helps anywhere where you need to coordinate massive amounts of people, right? There's like an economic benefit sometime, and then there's like an ethical benefit. We wouldn't need a blockchain if we weren't in a position where centralized organizations were abusing their power, right? If like internet providers weren't abusing data privileges, we wouldn't need a blockchain. If political parties weren't abusing their power, we wouldn't need a blockchain. And something that Vitalik Buterin said a long time ago, which I really liked, is like a lot of technologies are all about automating people's jobs on the outside, on the fringes, jobs away. And blockchain's about automating the like coordination people in the middle jobs away, right? For example, applying it to Uber, AI automates all the drivers away. Blockchain automates Uber away, right? Like a blockchain version of Uber is where you just have the drivers, but you have no Uber. And that's the really cool part. It's like you get to automate the center away instead of the fringes.
All right, so I'm going to take this opportunity again, and again on behalf of ExpoLab and UC Davis, to thank you, Alex and Aaron, for joining us today. It was very exciting and
Thanks for having us.
definitely left us with a lot of interesting things to think about.
Thanks. Great to be here. Thank you, guys.
Thank you so much.